G'day. A short while ago a friend of mine brought a lathe backing plate and asked whether I could thread it for him. And looking at the part, I thought, yes, there's a reason he can't do this. Typically these things are made out of cast iron, a bit like this faceplate, but this is actually an offcut of steel, and so quite a bit tougher to thread. So if you haven't got a lathe with a bit of grunt to it, then you can be in trouble. The other issue too is the lead screw. The lead screw on this one is 8 TPI, but it can be geared down to less than that. But with some of the smaller lathes, particularly those with small motors, trying to get a very coarse thread out of them means driving the lead screw in a way that it takes a lot of power to push through. This one being a 4mm pitch is something like 6 TPI, and so that's going to make it a bit difficult for a lathe with an 8 TPI lead screw. One of the reasons that I thought this could be a good project was it gave me an opportunity to test out the new boring or threading tool that I made a few clips back. The actual threading of the backing plate took relatively little time, but getting it all set up, as is sometimes the case with these things, making sure I had all the tools and I had the correct setup was what took the time. I haven't got the lathe with me, so the first thing I've got to do before I attempt to cut this thread is to make up an external thread, a copy of the register, I guess, the lathe spindle, that I can use as a gauge to tell when I've got the part right. Now, I was planning on making this out of some 50 round that I had, but I've discovered I don't have that anymore. I've used it for other things. So I found a chunk of mild steel, and I'll round that up. That shouldn't be a problem. However, the problem is that there's a hole in there and it's not quite on the center of where I want to go. So what I'm going to do is I've just cut up some little chunks of steel, and I'm going to just weld those, not you know, all the way around, but just enough to hold them in place on the ends, so that I've got somewhere I can put a center pop. It's just one of those things that sometimes you have to do this stuff. If it was a problem where the hole was in the right spot but it was just too big, I could put a plug in there, but because it's going to be off center, there's a chance that could move. So a spot or two of weld on there is probably the better way to do things. I've welded my blocks onto the ends here. Now, one part of this was saw cut and the others were machined. This is just a scrap block of steel I had sitting around the place. So I've measured across there, then used a height gauge to set that height, and then come up that same height from there, and that's how I've located that center. I'm now going to do the same thing, put it into the 4-jaw chuck and indicate off these 3 sides to position it in the 4-jaw chuck. I tried lining this up in the usual way, using the sides of the block here, in particular centering on these 2 and then lining that one up, because as I was saying, that one's a saw cut. But that didn't work too well. I couldn't get it so that it wasn't shaking the live center around the place. So what instead I've done is I've put my indicator on the live center and got that into the center I've put in there. I've now dialed in the chuck so that the indication on the dial indicator there is what's that, 0.02 of a millimeter on the center. So that means that the center is going to be lined up with the axis of the tailstock. I'm not quite sure what this end is doing. I had hoped, because I had a square face there, it'd all sit nicely. But once that's done and I've got this rounded off, I'll then flip this round, put this into a 3-jaw or something like that, and just neaten that up so it's not going to matter too much. Back on lathe cam now. I've end-for-ended that. This centre was a little bit out, but I had enough there that I could redo that centre and get it back on centre. So that's all good. That goes in there without shaking around. This is all dialed in. I've taken that down to 39, or actually 38.9, so slightly under the 39. I've also marked off here the register depth. So that's basically where my thread needs to stop, or my full depth thread needs to stop.
because that being a close fit in the register is what locates the chuck, or at least that's what we're told. I'm now going to set up for my threading and put the 4mm pitch on that, and then once I've got that done, I can pop that block off, and that should be just a matter of coming with a parting tool probably and knocking those welds out, and that'll pop off. And then I'll be ready to start working on the backing plate itself. There's my finished gauge. I took off the end pads just by running a parting tool in there to take out the weld, and then the pads just fell away. And as you can probably see, the hole and the radius of turning or the radius of the parting where it's dug in there is different enough to make it a problem. At one stage I was thinking about boring the middle of this out just so everything was concentric, but I thought, well, that's probably a little bit too much work. That screws into there quite nicely, so that's a nice snug fit. Comes back out again. Now, a couple of things on screw-on chucks. First of all, they have a thing called the chuck has the spindle has a thing called a register on, which is this bit here. And the idea behind that, I think, is that that surface is meant to be a close fit for the inside of the bore of the backing plate or whatever's screwing on. That surface there comes into contact with that, and so between that and the screw thread to hold it on, that's meant to register the chuck in the same spot. So it's important to get these surfaces there and get them, reasonably sized. Some people say no, it doesn't work that way at all. I don't know. I use a cam lock chuck. If you ever have a choice between a lathe with a cam lock chuck and a screw-on chuck or something like that, I would suggest taking the one without the screw-on chuck, because there are a couple of things that a screw-on chuck can't cope with. One of them is if you have a lathe with a brake and you apply the brake suddenly, you may get the screw-off chuck wanting to come off, and then it rolls off and onto the floor. It also means you can't run the chuck backwards, because the forces there from the cutting tool are going to be unscrewing forces. One question I do get asked occasionally is what size chuck should I have on my lathe? Normally with a new lathe you get a 3-jaw chuck and a 4-jaw chuck and a faceplate, but with a second-hand lathe you may not get any of those. You might have to scrounge your own depending on what the condition is and all that sort of thing. The rule of thumb seems to be, from looking at a number of specifications, is that the diameter of a 3-jaw chuck for a lathe is about half the swing. So this lathe's got a 12-inch swing, so I'd expect to get, if this was new, I would have expected to get a 3-jaw chuck with it, a 6-inch 3-jaw chuck with it. And the 4-jaw seems to be the next size up. So this is an 8-inch 4-jaw, and this is the size chuck that I would expect to find on this lathe. Now, I don't know why they have those limitations on. I suspect it's because the chuck jaws can come out and whack things if you're not careful. So particularly when you're doing work with large chucks and the jaws are extended from the chuck, spin the lathe over by hand and just make sure that the jaws don't collide with anything before you power up. Normally when fitting a backing plate to a chuck, the first thing you'll do is, if the thread isn't already there, put the thread in and then mount that on the spindle and turn everything else. This one has been partially machined. To try and minimise any eccentricity from the mass not being on the axis of the lathe, I've dialed in the outer here. I'm going to bore there. There's a couple of holes here which I think are mounting holes for the chuck. I'm hoping that they are concentric with this outside boss here. It may mean that there's a skim is needed or some repositioning of chucks. This side of the backing plate is unmachined, and so it should be, fingers crossed, all right, that once this has got the thread in it, it can be mounted on the chuck and checked and machined off, and the steps put in and all that sort of thing. The other thing I'm going to do with my indicator is actually check what the axial run out is like, because it may be that this is good, but this is not square to it. So I may have to take a bit of a skim off that. We'll see how that goes. So there you go, a little bit on putting threads into lathe chuck backing plates, and some of the steps that I do to do that. I hope that's been of use to people. Please share and spread the word, and we'll see you for the next clip.